Welcome back to BAS 120. This is Chapter 5, the homework. I want to walk through a couple of the homework problems that folks had some problems with. 26 and 37, and if there's more or if you still don't understand these, just let me know. This first problem, number 26, we were told that there was a 4% chance that rooms would be canceled, and we had a total of 300 rooms. And they wanted to know what's the probability that at least 280 rooms would be occupied. So if you think about it, that's the same way of saying we would have 20 or fewer cancellations. So if we wanted to figure out the probability, we would use our binomial distribution. And let me do it here for you. Let me do it again here. We would just go up here and we would say fx. We would find our binomial distribution. We would say okay. And the thing I like about Excel is it tells you exactly what it's looking for. The number of successful trials. Well, the number of successful trials would be 20, right? Because we're defining success as a cancellation here. The number of trials would be 300. And the probability would be 0.04. 4% cancellations. Now this last thing, cumulative, we want 20 or fewer cancellations. We just don't, if we said false here, we would get the probability of exactly 20 cancellations. That's not what we want. We want a cumulative. We want to know the probability of 20 or fewer. So we will say true here. So Excel gives you the choice. It says, well, do you want 20 or fewer, or do you want the probability of exactly 20? So we want 20 or fewer, and so we'll say okay, and we'll get about 99%. So there's a probability about 99% chance that we will have at least 280 rooms occupied. And that can help us with staffing, etc. Hopefully you can see all sorts of potential business opportunities here. Then the bottom half of this asks us to calculate this using a normal distribution approximation. Okay, and the point here is we probably are going to come up with a number not exactly the same as the binomial distribution, but fairly close, because with 300 trials, as your n goes up, the binomial distribution tends to take the shape of a normal curve. It'll never be exact, but it should be close. So we probably ought to get a number somewhere around our 98.9 or 99%. So let's talk about how we're going to do this. First of all, the mean, if you remember over here for a binomial distribution, our mean can be the number of trials times the probability of that success. Now for this example, I'm going to switch around to make it easy on ourselves. Let's call success that a room is occupied. So remember our converse formula. If there's a 4% probability of cancellation, there's a 96% probability, 1 minus the 0.04, 96% probability that the room is occupied. So all we did here is we just said there's 300 rooms and there's 96% chance that it's occupied. To multiply the two together, you get your mean of 288. So now we know the mean. The next thing we need to figure out is the standard deviation, right? Which we know the standard deviation is simply the square root of the number of trials, which is 300, times the probability of success, which is 0.96, times the probability of failure, which is 0.04. So there we go. We got our standard deviation. Now, once we have our standard deviation and our mean, and we know what score we're trying to look for up the probability, we can determine our z-score. So this is simply the score we want to know, 280 minus the 288, which is the mean, divided by our standard deviation. So we know we're negative 2.35 standard deviations away. Now, the thing to remember is a normal curve, which should I put? A normal distribution is we're going to read the chart from left to right. So if we want to know the probability of 280 or more rooms, to get the probability, we're going to have to do 1 minus norm disk, because the normal distribution is going to say from left to right. We want to know 280 or more. So it's 1 minus the normal distribution of getting 280 given what our mean is and our standard deviation is. And again, we're going to say true because we want it to be cumulative. And that'll give us the probability of 280 or more. And you can see it's 0.9907 versus 0.9899. A little bit different, but very close. And the point is you have large n's, the binomial distribution looks very similar to a normal distribution. That was problem 26. If you still have questions, let me know. Number 37 was another. Here I put in the bell-shaped curve. So just a quick point. The probabilities you'll get are always reading from left to right. So like in that last example, if I want to know the probability of this area over here, 280 rooms or more, what the computer will tell me is the probability from left to right. So if I just want this area, I'll do 1 minus this probability. Problem 37, DVD purchases. They told us the mean was they purchased $20 worth and the standard deviation is 4. What's the probability of at most 15? So again, at most is 15 or fewer. So we're reading from left to right. So we just do the norm dist equation with the information, the mean and the standard deviation and the score we want. So it's 15 compared to the mean, compared to the standard deviation. And the 1 just means we're saying true. So it's cumulative from left to right. And then here's the at least is just 1 minus whatever that was, right? So 1 minus that amount. Then it says, what if there's 100 customers? What's the mean of 100 customers? Now, this is an important concept to kind of understand. So this is going out, what if we went out and sampled 100 people and took the mean of 100 people? The mean's probably going to stay very close to 20 or about the same. But look what happens to our standard deviation. It goes from 4 down to 0.4. And if you think about this for a moment before we get into the equation, that kind of makes sense, because if I say to myself, what are the odds that I go randomly pick a person and they're over 6'3"? Well, that distribution is going to be pretty wide. But if I say, no, I'm talking about taking a sample of people, a sample of 100 people, what that's going to do is that's going to shrink down my deviations because I'm taking the mean of the samples. So the exact equation for it is the sample standard deviation is the standard deviation divided by the square root of the number of n's, the size of my sample. So the more I'm taking samples, I'm going to shrink that standard deviation, which is an important concept to sort of understand. As I take larger and larger samples, my deviation is going to shrink. So if you think of it like political elections, if I do a sample of 2 people, my deviation may be very, very large. As I take a sample of 1,000 or 10,000, I'm probably still going to get somewhere around the same mean, but my deviation around that number is going to shrink a lot. So the last part of the equation is says, well, okay, what is the probability that at least 40 will spend at least $15? So now we're talking about a binomial distribution in this last one. So I've got a binomial distribution. I want to know at least 40, so 40 or more. So again, I'm going to do 1 minus the binomial distribution. I know the number I want is 40. I know what my number of trials are, 100. And I know the probability of success is 89%, because we just calculated that in the first part. The probability that they spend at least $15 is 89%. So if I want to say what's the probability that at least 40 will spend that much on a sample of, I just do my 1 minus by binomial distribution, 40, 100, probability 0.89. And again, I say 1 or true because I want the numbers from left to right. Hope this helps. This was a tough chapter. The next couple of chapters are going to be fairly intense. So holler at me if there's something you don't understand. Hope this video helps. Have a great day.